Right, so I've built an exciter circuit, and it's actually the very common Slayer exciter that uses a 2N2222 bipolar transistor, which doesn't have a lot of oomph, but we're going to see if it works. And what we've got going on here, let me just get in a bit closer. Right, so this is the circuit that we've built with a 2N2222 bipolar NPN transistor driving the primary, and an LED used to limit the base drive, and a 2K2 resistor providing the base current. The whole thing's going to be run from 12 volts. So I've got my power supply set up for 12 volts, and I've got it current limited at 200 milliamps, so if the little transistor does go bang, hopefully it won't go with a big bang. And if we zoom out, here we can see the whole setup. So I've got my ancient trusty 4-channel scope hooked up so I can see what's induced in the secondary. I've got the first channel is just a loop of wire around the secondary. The second channel is looking at the cathode of the transistor, and the third channel is looking at the base signal of the transistor. So here's the circuit on the breadboard, and you can see that the primary is just 3 turns of wire wrapped pretty much anywhere around the coil. And I've got the top hat on and the scope here ready to have a look at things. So I'm going to turn the light off so we can see the scope a bit better, and hopefully this will actually record okay, because we have some potential strobe effects between the recording rate of the camera and the refresh rate of the scope display, this being an ancient cathode ray tube device. So I also want to point out here that if you're generating thousands of volts, you don't really want the top part anywhere near to electronics equipment like the power supply, multimeter behind on the bench, the oscilloscope, or my audio output from my iMac. But I don't think we're generating, well, we're going to generate an awful lot of power, so we're going to give it a go. I also have to point out that my finger has to get on the power supply to turn it on, which is a bit close to the coil. But anyway, we're going to give it a go. Alright, so inquiring minds want to know. Well, look at that. You can't hear it over the humming of the scope fan, but I can hear hissing from over here. And if we look at the power supply, you can see that the voltage dropped down to 2 volts as the current limiters come in. If I turn it back off again, see, I had it set up for 12 volts at 200 milliamps. Well, obviously it's planning on taking a lot more than 200 milliamps. But looking at the scope, it is in fact oscillating. And if you look on here, I have a power LED here across the 12 volt supply, and this is the LED between the base of the driving transistor and ground, and it's glowing pretty decently, so I'd say there's a milliamp or 2 going through there at least. And is the transistor hot? This is the point where you burn your finger. Yeah, it's pretty toasty, so it's probably going to explode in a minute. But it's working, and on the scope, the top... Whoa, baby. Get away from there with my nice smartwatch. Did you see what happened there? Look, as I get closer to it, I'm changing the capacitance. So you can see that the resonant frequency here, well, you can't see, but I can. We're looking at about, it's 500 nanoseconds of division, so 1, 2, it's about 150 nanoseconds. So I'd say it's oscillating at around 600 kilohertz there. And you can see this is the driving signal on the collector of the transistor, and this signal here is what's on the base as it turns on and off. So it's driving very nicely. And you can see that there is also a higher frequency signal in there that's got quite a lot of peaks to it, and if I bring my fingers closer to the coil, it starts to become predominant. And I'd say that's, let's see, 1, 2, 3, 4, 5, 6, 7 or 8 times as fast. So a few megahertz there, so it's probably driving radio listeners in the vicinity crazy. Can I feel anything? No. But if you watch the voltmeter over there, you can see as my hand gets nearer, it drops even lower as it goes into current limit. Well, not surprising really, because if you look at the power supply, it's down to 2 volts now and 200 milliamps. I'm going to turn it off for a second and take the top hat off and see what we get. So it's off. Now there's no big capacitors in here, so there's nothing to discharge. This is not dangerous. So we'll lift that off. Turn this back on. And interestingly, the signal actually looks a bit cleaner. Doesn't want to light this tube up. It's not go crazy. I'll put it up to 300 milliamps. I'm waiting for a small explosion from the transistor down there. So now we've definitely got a bit more signal. So we're running about 1 watt into the circuit. Oh! Ha ha ha! And we have takeoff. Is the transistor hot? Ow! Yeah. Yes, it is. Right, well I thought we'd bring this thing out here and give it a go where there's less stuff for it to interfere with, and also there's more space around the top hat here. Speaking of which, put this enormous thing on, back on. Now, as was evident inside with this little bipolar transistor driving things, we're not getting a great deal of power capability here. But that's okay for now. I've got some MOSFETs coming in the post, which should be here in, I don't know, a day or two. And we'll see how it goes then. So, turn this thing back on. And we got it limited at 300 milliamps. So, a little over 3 watts. And we know it's oscillating. We can't see anything, so I'm going to turn the lights off. Oh, there we go. Interesting. So we've got quite a lot of radiation partway down the tube here. The current limiter is running, so we're only driving it with a little under 1 watt. Let's take the top hat off and see what happens. Ah, interesting. So, actually I can't tell if it's really actually any different. So in the interest of science, I thought I'd wind the current limiter up. I don't know if you've noticed, but it's now up to half an amp at 12 volts. So I suspect that 6 watts are going to set fire to the little bipolar transistor, which is, can't really see, there's this little black guy sitting here. It's a 2N2222, which is a pretty generic little NPN guy, and I'm amazed that it hasn't broken down yet from high voltage across it, collector to emitter. So I'm just going to leave this top hat on without the big one. I'm a bit concerned about the sharp edges here. Hadn't actually intended that we run it like this, but it doesn't really matter for the moment. So I'm going to turn the power supply on, see what happens. Alright, so we've got 2.5 watts coming out of the thing now. Oh yeah, oh, it lights up much further away now. I suspect it'll catch fire in a minute, but we'll see. And how hot is this now? Ah! Ooh, ah! Alright, well it gets very hot for viewers at home. I'm going to try and experiment with a little piece of wire, so hold on a minute. Oh, well, you may notice that the power has gone to 0 and the current has gone to 0, so I think we have sacrificed our transistor. I really burned my finger just now. It's an electro boom moment for those of you who are fans of that particular YouTube channel. So I'm pretty sure we just fried that. So, yeah, 0.5 amp, definitely more than we can manage. So I'm actually going to take that down a bit. Let me go find another transistor, and then we'll see if we can get any ions out of here. Alright, so I've replaced the transistor, and I've removed the top cap and just left the wire sticking out the end. I'm suspicious that the overall capacitance of all of this to ground is really not affected by this top cap, so I'm hoping to get a much higher field density out of the wire at the top. Don't know what it's going to do to the frequencies. We don't have the scope out here, so got everything ready. Alright, let's turn it on. Alright, it's oscillating. Bring my light bulb up near it. And it really still lights up in pretty much the same places. So I think we've got reasonably high voltage. It's possible that this tube is a bit tall and thin. They're a bit more efficient when the aspect ratio is a bit more towards short and squat. A situation I'm personally approaching. But it does work, and obviously this exciter circuit is very, very limited. And when I first saw this diagram of the exciter with the little bipolar signal transistor in it, my first thought was, well, that won't do anything. But it certainly does. Let's turn the lights back on. One thing that I didn't mention is that this primary coil has to be connected so that the positive supply, which you can think of as going to the top, is on this terminal here, which goes around this way, and the bottom end of it is connected to the driver transistor. You can see on the diagram the phase of the two coils has to be opposite. If you reverse the connections on this primary, it won't oscillate because there isn't any feedback into the base of the transistor. So that's what the two dots on the diagram are. So I'll give it one more go. It's on. The LED is on. And yeah, it lights up. But Notice that I'm wearing my safety flip-flops. Interesting, it stops oscillating when I touch it. And the current tends to max out because as soon as the transistor stops oscillating, because it's got a resistor from 12 volts into the base, if there's no oscillation feedback here, there's no AC, then this transistor is just turned on, and this short coil of wire is pretty much a DC short circuit, so it'll just pull the power supply down until it's low enough that the transistor is just about on, but it won't oscillate like that. So there we are. Clearly what we need is more power.